That's just a mixed bag of screws in here, eh, bud? Fortunately, this thing just pops right out. All these little connectors, just get them on the loose. Hey, this guy. Okay, the subject in question is this guy. That is my triple bay Sata Hotswap. It is the backbone of my storage infrastructure. I have NAS, but why keep crap you don't need to access online? I just offload it, put it to cold storage. Yes, every now and then I shuffle around because I know about bit rot. So either way, buddy. Now, the problem is these fans. This guy's old. Probably had it over 10 years at this point, if not more. Is there anything resembling a date on this? But either way, I go to use this thing and the fans are like, yeah, can you friggin' not, bud? Eventually they settle in, but still, that first little bit's annoying and sometimes just like, it's too much noise. Let's see if we can simulate this experience for you. So in order for it to work, you have the back plane here. You have SATA and SATA power. SATA labeled data. Now, what happens is you need to use these special adapters that it comes with if you want fan functionality. So you could plug directly SATA powered SATA into this and it'll work, but the fans won't run. Now, that's good and bad. It depends. I have it wired up so that if I only use one, the fan doesn't run, but if I use more than one, they do. And that simply has to do with these outputs here, or those are actually inputs. So what I'll do is I'll hook direct SATA power up to there, but I'll use these adapters on these two ports. And then what happens is these little extrapolations will plug into these two ports and two things happen. In the SATA power connector, not a lot of people might know this, but there's actually a hard drive activity light output. Now it's a pin that would normally get grounded by a typical SATA power connector, and I have hacked SATA power connectors before, grabbing one of those ground connections. Oh, you can even see, right? You got red right here where another ground wire would have been. It's the two smaller wires. I guess it's an open collector low would be the output, and those will output a hard drive activity signal, and then that sends the hard drive activity signal to here, and that's what makes the lights blink. So you have to line these up with the proper connectors if you want the proper light. I actually had it misaligned for a while there, didn't bother fixing it, and that light blinked when this drive was working. The light won't work at all if you don't use this. That said, it also sends 12 volt power into this backplane assembly to run these fans. So that's how that works. Now we will go ahead and we will give it power. I don't know how much of this is going to work under these circumstances. Now we're going to grab a drive. This is a not good condition drive. We're going to put it in there. There's no 5 volt power. I don't know if the drive will actually run. Oh. The fans will. And it's funny, even though you only use one, both of them go. Yeah, that's enough of that, bud. It seems it's this top one's the worst. It's almost like if you activate the drive, there's another pin that like bridges power or something. But this should be a simple process. Oh, that pops right off, bud. Oh, we have this wire going to the front. Oh, look at that, how convenient. A disconnect, except we're in a position where we have to remember where it goes. There's like more going on here. HD4, apparently this is a generic board to support 4 drives. I'm gonna like black out this general selection so that we know it doesn't really go there. And then I'm gonna put a mark here to maybe signify the top we can see. And then boom, we got this here now, which should make the process relatively simple. At least for me. I don't know about you, bud, because we gotta disconnect these guys. We gotta unplug these guys. And these appear, just as I predicted, are common JST connectors. So what I've gone and done is on the last digit-key order, I slipped in these. These are part number MF40101V2-1000U-A99, for short 259-1797. Sunon, a whole $7 each. Not too bad. But they say maglev, fancy magnetic levitation, man. You pay premium to get Corsairs with that feature. Specifications, 12 volts, 0.59 watts. And they're keen. They're keen, bud. So, you know, these old fans didn't really have specs on them. Like, you look at it, it just says 12 volts. It doesn't say their amperage, it doesn't say their wattage, it doesn't say their RPM, so I kind of had to guess. I guessed these ones. 7 CFM, 20 dBA, I don't want them to be too loud, 480 milliwatts, they clearly say 590 on here, 5800 RPM. I haven't even fired these pups up yet, I don't know what they sound like. See if we can just jam these in here. Come on now. Kind of predictable. It's kind of what I expected. I'm kind of expecting I might have to do some modifications to get this where I wanted it to be. Idea being maybe, just maybe, if I put some resistance in here, I can kind of throttle these down. I'm gonna look at the other side of this board, see what my options are. There's some resistors on there already. Pretty sure that has to do with the LEDs. Oh yeah, it's got diodes. That way the various power inputs. Oh look, it even has a spare connector. They just blocked it on this backplane. So even this backplane is designed for like multiple more, even though you couldn't really fit 4 drives in this footprint. Maybe they use the same backplane for 2.5s. They have all these diodes so that you can merge the different 12-volt sources together without them conflicting with each other. I don't care to elaborate, but they will provide some voltage drop to maybe tame those fans a little bit. It also does potentially give us an ingress point which to add more voltage drop if we wanted to. Either way, we won't know what we're dealing with until we deal with it. So we'll go ahead and get these fans mounted on here. They were mounted as exhaust fans. And there's a little nip there for the wire to go through. Oh, the wire doesn't line up to the same spot as the pre-PA fans, bud. Oh, aren't you just a little conflictor? Slight curveball. It'd work if we made them push intake fans. Okay, I guess it's a simple case. We gotta notch the plastic in that one spot. You know, maybe right about here. A round file should make a round notch. It's a bit of a thick boy though. Where's my thin boy? There it is. Smells wonderful. Other than getting debris everywhere, it did generally accomplish the goal we were after. Still a bit tight, eh? Okay, a little bit, just a little bit more. So, yeah, the rest of those screws go in after the fact. But now we have wires. Nowhere to go. Gotta kind of get them down here. Oh, we got these nice wire channels. They fit nice in there. What polarity is what here? So yes, red's top. That's good to know. So we need to right about like that. Maybe there. All right, don't be cutting these too short now. So now we're totally gonna bust out our JST crimping connector kit because I know y'all have JST crimping connector kits. Gonna need about 4 of these little peps here, pipsqueaks. And yeah, pair of doolies. Need to strip just a little snit off the end, just like that. Gotta make sure we orient these. Goes in like that. So the lock is at the bottom. That's good. Sometimes we can kind of pinch these on so that they stay put for a second. Long enough for us to get them in the tool. And sometimes, no, we can't get them to stay put. We gotta preload them into the tool if we don't just lose them. Just start to bite down on it until it just stays there. Oh, that one went a bit funny, but it's gonna work. So red and black and plug it in. Look at that. I'm so glad I invested into this tool. It's like it was meant to be, but it just goes in there. Actually, I think these are slightly out of spec. It doesn't look like it well, no, it's okay. Actually, yeah, mine are just slightly a different shape, but still within acceptable tolerances. Kind of missed the mark with that one a little bit. If you're interested in this, just search, where is it? Used to say, oh. Preciva. Search that on eBay or Amazon. You'll find it. Okay, now is this gonna fit? Now I want to do an initial function test, see here how much it's going to noise up on me. So if I have to tame these Impalas, I'm going to want to know about it before I get it in the computer. Just chuck a couple screws in here just to say it's not completely loose. All right, time to enter the simulation. Plug that on there. Get that on, and then ta-da. Turn it on. Let's get a drive in there. Huh, such a smooth sound. Can confirm the drive's not spinning up. Doesn't have 5-volt power. All I hear is air noise. I don't hear like rattles and zings or anything. They're so smooth. I have an idea, a nasty idea. exactly how I want to implement it though. Okay, I have a flan. A flan. Actually, no, I don't have flan. I have a plan, is what I have. So, as mentioned, if I just use one bay, the fans don't turn on, and it's usually the bottom bay with the philosophy that heat can naturally rise off of it, and there's airspace in there. It's if I use the other two that the fan kicks on. I'm gonna configure this so that if I only use the top bay, the fans will run at half speed because there's still air room in there. But if I use the middle bay, the fans will kick on at high speed, full speed. How am I gonna do that? I'm glad you asked. We need to take this part back again. We need to take this back apart. So seeing here in our control board, we have 4 diodes. We only need to have 3. But we need to get perspective here. It goes in like that. That's one. We're gonna mark red as the one that we're gonna modify. So now we can see it now that it's upside down and backwards. So it's this one here. So how this works on the quick and dirty is we have multiple power inputs. They go through a diode, then they converge together on a power bus which runs our fan. These are one-way valves of electricity, so power could go this way to run the fan, but it cannot go that way and interrupt the extra base. So either one of these are powered, it's gonna start the fan. Now if we take one of the other connections, I'm just gonna draw another one, and we add some sort of limiter. When we use this one, the fans will run slow, but when we use the other one, the fans will run high. So I marked red, that's gonna be the full speed. We're gonna figure out which one of these is gonna be the low speed one. We're gonna remove that diode. We're gonna put some resistance in there. We'll still need a diode, but we'll put some resistance in there so that we can regulate that fan speed. First thing we need to do is figure out what resistance. So we need to do a test. All right, I got my specialty meter here. It's gonna tell me how much current we're consuming. I got this adapter here. We'll plug that in. We got an arbitrary wire. We'll plug into the negative of 1, the negative of a fan, and then we'll get a some arbitrary resistor. Like this right here, a 10 ohm. And it's tiny, but it's a 1 watt. Put that on the positive. Fan spins up, it feels it's going almost full power. This guy's saying we're at 39 milliamp hours. We use our multimeter to confirm this, connect it across 2 sides of the 10 ohm resistor. And yes, we see we have 0.4 volts of drop. So that's 40 milliamps. So if these poppers are going to consume 40 milliamps, well, they're going to consume less if we tame them down. Well, right off the bat, I can tell you right away, if we put a 100 ohm resistor in there, it should drop 4 volts according to this data, but not necessarily, because you'll have less drop as you decrease your voltage. We also could go as far as to just put a little regulator in there, but that means we have to make a circuit, a functional circuit. We'll need capacitors so it doesn't get angry. So here's a 100 ohm resistor. Sure enough, running much slower, 28 milliamps. Meter confirms 3 volts of drop. However, 3.03 divided by 100 ohms. Yes, 30 milliamps times 3.03 volts of drop is 0.91 watts. Okay, so this 1/4 watt resistor can handle that. However, we have 2 fans that we need to connect. So let's start getting fancy. Right, gonna kind of jumper rig these fans together some way. Oh, and of course with more load we got more drop. Now we're dropping 4.91 volts, which is gonna be roughly 49 milliamps, which is a oh, that's 1/4 of a watt. So this guy's gonna start getting toasty. I feel like that's about where we want it though. I have miniature 1 watt 220s. That's gonna give a more profound effect, but we'll try it. Oh, they're right slow now, bud. We're dropping 7.5 volts. Divided by 220 ohms, 34 milliamps. Multiply that by the voltage, 260 milliwatts. So this 1 watt's gonna be fine. And you know what? This might be nice. Like it's mellow now. You can barely hear it. I think this should be good enough just to say we'll get some ventilation and cooling when we have 2 drives running. So yeah, but I think that'll be the sweet spot. 220 ohms. Okay, now we just have to implement it. Now we need to determine which route on this back plane is the route that we would be using. So again, it goes like this. Red is the full power one. 3 is not used. Black will be the low power one. So black's there. It looks like one of the outer terminals is going to be positive. Ugh, gotta reverse engineer this tiny little thing. The diodes are pointing that way. It might be the negative bus that switched, or that the diode's on. Okay, no, those negatives go directly to these 2 holes here. Fan control is there. We've got a big negative backplane for fan control. Ah, yes, okay. So the diode, I think it's coming off this outer pin. Oh, we gotta do some impedance testing. I believe it's gonna come off this outer pin to there. No, where's it coming from? Oh, it's coming from a negative pin. Okay, so this big plane here is positive. And then yes, the diode is faced backwards to a negative bus that goes to the fans. So either way, that diode right there is the one that we need to change or manipulate on or modify on. Which is gonna be tricky to get in there. It's a little bit surgical. It's a little bit surgical, bud. Wetter tip. Now this diode's not gonna be going back in there because of how we're gonna do this. Now we need to use a diode. I think a 4148 should do, but not this one. This one's testing bad. Ho ho ho. No wonder some of my experiments go awry. I got freaking bad diodes in the reservoir. This one tests good. We haven't got a lot of room under here. That's the other problem. However, it's this pin and it goes to this hole. So we could diode into this via. Really? All right, well, if in doubt, meter it out. You can't see my meter readings, but so it's this pin to that pad, which means it also connects to this hole to that resistor. So I'm looking at this thing and I'm seeing these ridges don't give me a lot of room right beside the connector where the diode is, but there's room here. So if I say located this resistor right about here, we need to crop lead right about there, and we connect it to the bus pad. Then we get our diode pointing inwards on that shared via. Ugh. Then it's just a case of binding these two puppers together. That should do it. Kind of want to test it before we button this up and cut these wires. Get some French connected, and we'll double down on this. Okay, we can't connect those both at the same time. Is that what you're saying? Just need a little split, bud. Just give me a little split here. Right. You need to calm down. Okay, so on our power feed here, we're going to establish a Y. Why? Because we needed to go both of these. Then we needed to attacher. Well, we need to establish bay 1, this top. Bay 1 output is here. We'll plug that into bay 1 input here. Bay 2, bay 2. Get it some power. So, if I did everything right, when I plug on this one bay, slow fan speed. Yep. Grab ourselves another questionable drive. And if we slam it into bay 2, what effect do we get? Huh? Nothing? Okay, we need to dummy check, sanity check. Maybe this drive isn't compatible for whatever reason. Let's try it in bay 1. Oh yeah, no, this drive doesn't want to pass power. Okay. Well, what happens if we put this drive that we know does in bay 2 full power? Let's try a different drive. Let's try this in bay 1. Confirmed, bay 1 full power, or no, half power. Activate bay 2. Full power. Bay 1 out. Back down to half power. And because of that diode, they shouldn't conflict with each other. It should work exactly as intended. Geez, this turned into a bit of more of a to-do than I was expecting, bud. Let's button it up. So we got leads sticking out the arser ender here. We need to crop that and then crop these. And hopefully, if I got my spatial skills correct, this should still fit in here. Yes, good. Oh, that's in place. Look at it all put back together, bud. The only thing is, sometimes I use the middle bay without using the top bay, so it's gonna suck that it just like, you know, it rips, but whatever. She'll be good. Alternately, one thing that I can explore, it's the other idea that I have is building an actual circuit. Like having the dropper, but having it like MOSFET controlled with a logic gate. It seems that it's on the negative, which is convenient because we can use something simple like a 2N7000. That basically when we activate it, it's gonna bypass that resistor. We can put the resistor on the global input or just generally the outputs to the fan. So that's always active unless we bypass it with the MOSFET. And then, you know, we could get a simple logic gate. I'm pretty sure somewhere I have like a sub-miniature, tiny logic gate around somewhere. It'd be like an AND gate. This plus this would be a high output, which would activate that transistor. And then boom, if we plug in two drives at the same time, full power. But if we only have one, didn't matter which bay it's on, we'd only have half power. So I might consider improving this. We'll see. We'll see. It all has to do with, you know, form, functionality, like how much work we want to put into this thing for what I'm going to get out of it. In the meantime, I'm not going to bother showing you this guy actually operating. I think we're done here. I hope you enjoyed this. If you did, stay tuned, because that's a proper computer mod right there, bud. Proper. Yeah, I like to do those sometimes. Okay, you can calm down.